We are from Group 6 and today we would like to present the material about validity, reliability, and testing of assumption. Hello, my name is Dandi Ramadhan with last student number 021. So I would like to explain about validity. Validity is a cornerstone concept in research, representing the degree to which a research instrument accurately measures what it is intended to measure. It is a fundamental consideration in ensuring the trustworthiness and credibility of research findings. Simply put, a valid instrument does what it claims to do and it does it accurately. At its core, validity addresses the question: are we really measuring what we think we are measuring? If a test, survey, questionnaire, or any other research tool purports to assess a specific construct or variable, validity speaks to how well it achieves that purpose. For example, if a researcher designs a questionnaire to measure levels of anxiety, the validity of that questionnaire would hinge on whether it truly captures the multifaceted aspects of anxiety, rather than, say, stress, fear, or some combination of related but distinct constructs. A research instrument with high validity produces results that are truthful and reflective of the actual characteristics or qualities being investigated. Conversely, a research instrument with low validity yields data that may be misleading, inaccurate, or irrelevant to research question. This can lead to flawed conclusions and undermine the value of the entire research endeavor. Next, one alternative to test validity is using person-product-moment correlation coefficient by correlating each item's scores with the total scores. So there are two alternatives in making decision in the validity test. First, seeing the value of significance. If the significance value is lower than 0.05, the instrument is declared valid, while if the significance value is higher than 0.05, the instrument is declared invalid. Second, comparing the critical value of R table. So if the obtained value is lower than the critical value of R table, the instrument is declared invalid, while if the obtained value is higher than the critical value of R table, the instrument is declared valid. Now look at the example. Based on the output above, the critical value of R table at the significance level of 5% and with the respondents R40 is 0.312. Item 1 is valid because the significance value is 0.000, is lower than 0.05, or because the obtained value Rxy 0.613 is higher than critical value 0.312. Next, it is the guideline using SPSS to test validity. First, open the SPSS and then click Analyze, click Correlate, and then click the Bivariate. And then input all the data per item and total score per item. Next, check person in correlation coefficients. Next, check to tail in test of significance. And then check flag significance correlations. Click OK. Now, we have the validity from the data. So the significant value from the data is 0.396. And the sample 1, the obtained value is 0.535. It means the obtained value is higher than the significant value. So sample 1 is the valid data.
Hello everyone, my name is Novarum Rakhda with last student number 03, and today I would like to explain about reliability in research instruments specifically focusing on Cronbach's alpha as a measure of internal consistency. So, what is reliability? Reliability is defined as the extent to which the instrument's result can be considered consistent or stable. Reliability is a fundamental aspect of measurement quality. It tells us whether our measurement tool, whether it's questionnaire, a test, or any other instrument that produce results that are dependable and reproducible. And then when an instrument lacks reliability, the data it generates become questionable and any conclusion drawn from the data may be invalid. Example, if a teacher administers a test to her students on one occasion, she would like the score to be very much the same if she were to administer the same test again tomorrow. The degree to which a test is consistent or reliable can be estimated by calculating a reliability coefficient. This coefficient ranges from 0 to 1 with higher values indicating greater reliability. There are several types of reliability we consider in research. The first one is retest reliability. Its consistency of measure across time. Number two, inter-rater reliability. It's about consistency between different evaluators. Number three, parallel forms reliability. Its consistency between different versions of an instruments. And the last one is internal consistency. It tells us how well the items within an instrument correlate with each other. Alright, the next material it's about Cronbach's alpha. It is one alternative to test the reliability of an instrument is using Cronbach's alpha, which was introduced by Cronbach in 1970. For research purposes, a rule of thumb is that reliability should be at least 0.70 and preferably higher, as noted by Wallen and Frankel in their 2011 publication. Cronbach's alpha specifically measure internal consistency and how closely related a sets of items are as a group. It's particularly useful for questionnaires or survey with multiple items that aim to measure the same construct. The calculation takes into account both the number of items and the average intercorrelation among them. Now let me give you a practical example. From this picture, we can see that the Cronbach's alpha is 0.820 and then the n of items is 10. Because this value exceeds 0.70, we can confidently conclude that this research instrument is reliable. And now, how to using SPSS for reliability testing. So you have to follow some steps. The first one is go to the Analyze menu. Number two, select Scale and then choose Reliability Analysis. And you have to input all your data to items. For the model, choose alpha, and statistic you may checklist scale if item deleted and click continue and click OK. And this is the result of the all variables, and this data is reliable because the Cronbach's alpha is more than 0.70. Alright, that's all explanation from me. Thank you.
Hello everyone, my name is Jenifer Patricia Sirait and my last room number is 026. So today I'm going to talk about testing of assumptions. So in statistical analysis, parametric tests assume certain characteristics of the data, known as assumptions. If these assumptions are not met, the result and the conclusions of the research may be incorrect. As you prepare to conduct your statistics, it is important to consider testing the assumptions that go with your analysis. Assumptions testing of your chosen analysis allows you to determine if you can correctly draw conclusions from the results of your analysis. You can think of assumptions as the requirements you must fulfill before you can conduct your analysis. To ensure accurate interpretation, researchers must follow these assumptions. Different tests have different assumptions. Here are some common found in statistical research. There are assumptions of normality, assumptions of homogeneity of variance, and assumptions of linearity. Assumptions of normality: the data should follow a normal distribution, which is a symmetric bell-shaped curve. And assumptions of homogeneity of variance: the variance spread of two or more datasets should be equal or similar. If one group has much more variations than another, the results may not be reliable. And then assumptions of linearity: the relationships between variables should be linear from a straight line. If the relationship is not straight, the test may not give accurate results. That's all from me. Thank you.
My name is Bunga Ivana with class student number 022, and today I will explain about normality test. So, many of the statistical procedures, including correlation, regression, t-test, and analysis of variance, namely parametric tests, are based on the assumption that the dataset follows a normal distribution of a Gaussian distribution. That is, some assume that the population from which the samples are taken are normally distributed. With large enough sample sizes, more than 30 or 40, the violation of the normality assumption should not cause major problems. This implies that we can use parametric procedures even when the data are not normally distributed. For example, if we have samples consisting of hundreds of observations, we can ignore the distributions of the data. According to the central limit theorem, A, if the sample data are approximately normal, then the sampling distributions too will be normal. B, in large samples like more than 30 or 40, the sampling distributions tends to be normal regardless of the shape of the data. And C, means of random samples from any distributions will themselves have normal distributions. We can look for normality visually by using normal plots or by significance tests, that is comparing the sample distributions to a normal one. The frequency distribution or histogram stem and leaf plot, box plot, PP plot or probability plot, and QQ plot or quantile plot are used for checking normality visually. And then, to test the assumption of normal distribution, skewness should be within the range of approximately 2, while kurtosis value should be within range of approximately 7. The normality tests are supplementary to the graphical assessment of normality. The main tests for the assessment of normality are Kolmogorov-Smirnov or KS test, and then Liddy-Force corrected KS test, and then Saviro-Wilk test, and then Anderson-Darling test, and then Kramer-von Mises test, and then the Agostino skewness test, and then Anscombe-Klein kurtosis test, and the Agostino-Pearson omnibus test, and then for the last one is the Jacob-Berra test. The KS test is an empirical distribution function, EDF, in which the theoretical cumulative distribution function of the test distribution is contrasted with EDF of the data. A limitation of the KS test is its high sensitivity to extreme values. The Liddy-Force correction renders this test less conservative. The Saviro-Wilk test is based on the correlation between the data and the corresponding normal scores and provides better power than the KS test even after the Liddy-Force corrections. So, some researchers recommend the Saviro-Wilk as the best choice for testing the normality of the data. Normality tests are associated to the null hypothesis that the population from which a sample is extracted follows a normal distribution. So when the p-value linked to a normality test is lower than the risk alpha, the corresponding distribution is significantly not normal. If the significant value is more than 0.05, then the dataset is considered normally distributed. And if the significant value less than 0.05, then the dataset is considered not normally distributed. Now I will show you how to use SPSS to test normality. First, click Analyze, Descriptive Statistic, and then Explore. Then Add to Variable, and then click Plot, Normality Plot with Test. Click OK, and there are some tables. Now, let's take a look at the test of normality. There is two parts, Kolmogorov-Smirnov and Shapiro-Wilk. Both are determined based on the amount of their Smirnov and Shapiro-Wilk. Both are determined based on the amount of their respondents. For Kolmogorov, it is used if your respondent is more than 30, while Shapiro-Wilk used if your respondent is less than 30. If the value of significancy is above 0.05, then the data distribution is normal. Then, what if one of them is not normal? Then it is considered not normal. To sum up, if both of it normal, then it is considered parametric test. And if both of it or one of it not normal, then it is considered non-parametric test.
Hello everyone. In this part of the video, I will explaining about homogeneity test. What is homogeneity test, you ask? It's a key concept in statistics that help us to check if different data set share the same variance or not. This is important because many statistical tests assume that the data groups are similar in variance. If this assumption is violated, it will lead to incorrect conclusion. So now let's talk about homogeneity. Like we talk about homogeneity test, but we don't know what is homogeneity is, right? What is homogeneity? Homogeneity means that different groups in data set have similar statistical properties, especially in terms of variance. When the data set are heterogeneous, mean their variance is significantly different. This is matter because many statistical tests like independent t-test and ANOVA assume the variance across the group are equal. So homo is similar, hetero is different. So why do many statistical analysis require homogeneity of variance in their work? Because if the variance is equal, the test like t-test, individual t-test, and ANOVA work correctly. But if the variance is unequal and the sample size are different, the test result would be biased, one-sided, so it would lead to incorrect conclusion. There are several ways to check homogeneity of variance. Some common tests include Hartley Fmax test, Cochran test, Bartlett test, and Levine test. The most commonly used test to check homogeneity of variance is Levine test because it works well on the data when it's not normally distributed. Levine test check different group have equal variance by using F-test to test the null hypothesis that variance are equal. If the p-value or asymptotic significance is greater than 0.05, we fail to reject the null hypothesis, mean that groups have similar variance and the assumption of homogeneity is met. But if the p-value is less than 0.05, we reject the null hypothesis, indicating that variants are significantly different, and the assumption of homogeneity is violated. In such cases, using non-parametric alternative or adjustment like t-test is recommended to ensure accurate statistical analysis. Okay, here we have the data set. Have two groups, group 1 and group 2 with their score. Group 1 is Bahasa Inggris and group 2 is Bahasa Indonesia. How to find p-value on this group data set? It's actually pretty easy. You just go to the analyze and compare means, because p-value is based on means, right? So there is independent sample t-test or ANOVA. I'm gonna use ANOVA first. So I'm gonna reset that one jurusan or the group on the factor and the score on the dependent, and just go to the option and then homogeneity of variant test. Click that, continue, and okay, and you got the sig based on mean 0.658. I'll show you how to do it on the independent t-test as well. Here it is, independent sample t-test. Put a similar jurusan or the group on the grouping stage, grouping variable, and the score on the test variable. But on the group have question marks, so you divide group 1 and group 1 and group 2 and group 2. Yeah, group 1 and group 1 and group 2 and group 2. Okay, continue and just okay. And you also got the same. You got the same sig or p-value. It's above 0.05. It means that the variant is pretty similar or the same. It's homogeneity. It's homogeneity. Right, that's it from me.
Hello everyone, my name is Nyimas Hammada, and today we will discuss about linearity testing in statistics. So, what is linearity? Linearity means that two variables, x and y, are related by a mathematical equation y equal cx, where c is any constant number. In short, when we plot these variables on a graph, the points form a straight line or closely approximated one. The linearity test determines whether the relationship between or among research variables is linear. This test is a fundamental requirement in both correlation and linear regression analysis. Without this linear relationship, many of our statistical tools won't work properly. The interpretation of linearity test results follows two straightforward rules. First, if the significant values of deviation from linearity is more than 0.05, the relationship is considered linear. It means we can proceed with our analysis as planned. Conversely, if the significance values of deviation from linearity is less than 0.05, the relationship is not linear. So we need to transform our data or consider alternative statistical approaches. The test for linearity using SPSS follows these steps. First, put your data into the SPSS and then click on Analyze in the top menu. And then select Compare Means, choose Means, and then click on Options. Check Test for linearity in the statistic for first layer. Continue, OK. And once you run this analysis, SPSS will generate an ANOVA output table that includes the significance value for deviation from linearity that we need. And here's the result, 0.128. Based on the ANOVA output table, the significant value of deviation from linearity is 0.128. Because this value is more than 0.05, the null hypothesis stays still. Therefore, we can conclude that the relationship between the variables is linear. That's all from me. Thank you.